As we continue to work in Module 1, we have already explored what the different functions might look like, and we've moved on to expressions. In the last part of this module, we talked about polynomial expressions and how to combine them and simplify them. We are now going to move on to solving equations. Now, when we are solving, we are going to be solving two different things. We're going to be solving equations, and we're also going to be solving inequalities. Now, these two can be easily distinguished because equations will have an equal sign, whereas inequalities will have one of the inequality symbols, and it can be less than or greater than or equal to as well. Now, when we are solving an equation or inequality, we are looking for the values that make the equation or inequality true. Let's look at some examples. So when we're looking for values that make an equation or inequality true, we are looking for solution sets. You will often hear these two words, solution sets. What's the solution set of this equation? Well, the solution set of an equation is the set of values that one can assign to that variable to make the equation a true statement. Let's look at our first example here, number 9. We have z equals 2. That is an equation because it has an equal sign. Now, if we were to assign a value that was something other than 2 to z, so let's say instead of z, we would assign the value of 3, then this would no longer be a true statement. This would be a false statement because 3 is not equal to 2. So therefore, 3 would not be able to be in the solution set for this particular equation. And in fact, the only value that can make this equation true, so the only value we can substitute z for would be a 2. So when we are talking about solution sets, that's precisely what we're talking about. We're talking about what value can I assign to this one variable and still make this equation or inequality true. All right, so when we are talking about solving an equation or an inequality, we are actually looking for this particular solution set. And when we are looking for solution sets, once you find them, can be expressed in one of 3 ways. You can use words to describe the solution set, you can use a set notation, or you can show in a graph what the solution might be. Let's take this first example. We already established that the only value we can substitute the variable z for is 2 to make that true. So in this case, if I want to use my words to describe that, then I would say z equals 2 is true when z is equal to 2. Now, if I were to express the same, but using set notation, then what I would need to do is open up brackets and close brackets. And whatever the values are going to go inside of the bracket, and they are going to go in order from least to great. In this case, because I only have one value that can be substituted for z, the only value I can put in there is a positive 2. The last way to express a solution set is by using a graph. In this case, we have a number line, and if I want to show you that 2 in this number line would make this equation true, then all I would have to do is graph on the number 2. So let's go ahead and do number 10. So in this case, we have an equation. We have z squared equals 4. And the only way to solve this would be to taking the square root of z. That automatically cancels out my exponent, and I have z equals the square root of 4, of course, is 2. Now, we know from a square root that when we're taking the square root of a number, the answer could either be a positive or a negative of that number. So let me show you why. In this case, if I were to put this 2 back in the equation, 2 squared is indeed going to give us a 4. But what if we had a negative 2? If we raise a negative 2 to the second power, meaning we're going to have negative 2 times negative 2, that will also give us a positive 4. And that's where the whole idea of whenever you're taking the square root of a number, the value that you get is going to be either the positive or the negative of that value. So in this case, our solution set has 2 possible values. Z squared equals 4 will be true when z is either a 2 or when z is a negative 2. You can also express this using set notation. Now remember, when we are doing a set notation, we open our brackets and then we look at the values that are supposed to go inside the brackets and order them from least to great. In this case, our least value is going to be a -2 and the next value is going to be a +2. Those are the only two values that make up this solution set for this particular equation. If we were to graph it, we would graph a -2 and we would also graph a +2.